This will start off with a quick overview of how X-ray systems work. So, what are X-rays? Well, they are a physical phenomenon which involves electron release. Electrons are driven by a high potential voltage, and they go from an anode to a cathode and hit a metallic target. As the electron hits the metal target, the particle continues around the circuit, but the associated energy signature is released in the form of X-rays. These X-rays pass towards a detector by passing through the product. A detector is a range of different diodes which can come in various different sizes. They are assembled into a diode array, and they sit in between the tube and the product. So what does this look like in a system? We can see here at the top we have our X-ray tube. We can see here at the bottom, underneath the conveyor, we have our detector. And the red triangle in the center is the fan beam of X-rays created, so that as product travels from the left to the right, we can see which part of the X-ray is absorbed by the product, determined by the actual output from the detector below. We can also then decide what to do with that product as it's passed through. And in this drawing here, we can see that if a contaminant is identified in any of these products, it can be removed from the production line. If we think a little bit about how the actual contaminants are identified in the actual product, we can see, again, a tube, X-ray tube at the top, and a linear array of diodes at the bottom, our detector array. On the left and the right-hand side of the actual fan beam, we can see that none of the X-ray energy generated by the tube is absorbed by any product in the center. And this leads to an output from the individual diodes being very low. This is represented graphically in white. As we move into the center of the triangle below the tube, we can see that some of the actual X-ray energy will be absorbed by the actual product itself. As a consequence, the amount of X-ray energy that arrives at the diode is slightly less than at the outside. Therefore, the output from the individual diode arrays is slightly different, and it's represented in grey. In the center of the actual product, we can see a contaminant. Contaminants tend to be significantly more dense than the goods surrounding foodstuff, and as a consequence absorb more X-ray energy. This means that less X-ray energy arrives at the diodes below the contaminant, and therefore the output from the actual diodes where the contaminant is less. And it is this contrast that we look for when trying to identify contaminants in the images.